Welcome to Lesson 10, Partition Leader and Followers. So far in the beginner series, you learned how topics split into partitions, and how those partitions get spread across multiple brokers in a cluster. But there's one question we never answered, and in this lesson, we're going to fix that. Who's actually in charge of a partition when it's stored on multiple brokers at the same time? That's what the partition leader and followers are all about. Let's find out. Let's start with what you already know. From Lesson 4, you know that topics are split into partitions. And from Lesson 2, you know that brokers form a cluster, so a partition with a replication factor of 3 gets copied to 3 different brokers. But here's the question that's been hanging in the air. If the same partition lives on 3 different brokers, who does the producer send its data to? Who does the consumer read from? The answer is every partition has exactly one leader, and the rest are followers. That's what we're learning today. So what is a partition leader? For every partition, Kafka assigns exactly one broker to be the leader. That leader handles all reads and all writes for that partition. No exceptions. When a producer sends a message to partition 0, it doesn't pick a random broker. It sends directly to whichever broker is the leader for that partition. And when a consumer wants to read from partition 0, it also reads from the leader. The leader is the single source of truth. One more important thing, different partitions of the same topic can have different leaders on different brokers. So if you have 3 partitions, you might have 3 different leaders spread across your cluster. Now let's talk about followers. The other brokers that hold a copy of the partition are called followers. Their entire job is to stay in sync with the leader, constantly pulling new messages and keeping an exact copy. There's a clear do and don't list here. Followers do pull new messages from the leader, keep a perfect copy of all the data, and stand ready to step up if the leader goes down. What followers don't do is accept writes from producers, serve reads to consumers, or handle any client requests at all. Think of it like a head chef and a prep team. The prep team mirrors everything the head chef is cooking, every ingredient, every step, so they're ready to take over immediately if the head chef goes home. Let's look at a real example. Here we have a topic called orders with 3 partitions and a replication factor of 3, running on a 3-broker cluster. Broker 0 is the leader for partition 0, notice the crown icon. It also holds follower copies of partition 1 and partition 2. Broker 1 is the leader for partition 1 and holds follower copies of the other 2. And broker 2 is the leader for partition 2 with follower copies of the others. This is the key pattern. Every partition has exactly one leader, and every broker carries some leaders and some followers. The load is shared across the cluster. Let's trace exactly how data moves through this system. For the right path, the producer sends a message directly to the leader, in this example, broker 0 for partition 0. Once the leader receives and stores the message, it replicates it out to follower A and follower B. The producer never talks to the followers. For the read path, the consumer reads directly from the leader. The followers are there in the background, silent, constantly syncing, but they don't serve reads. The key point is this: followers are always copying data behind the scenes, but they never directly handle producers or consumers. The leader is the only one doing the active work. Here's where the real power of this design shows itself. What happens when a leader fails? In normal operation, broker 0 is the leader for our partition, with broker 1 and broker 2 as followers. Now imagine broker 0 crashes. Zookeeper, which you learned about in Lesson 2, is watching all the brokers in the cluster. The moment broker 0 disappears, Kafka detects the failure and needs to elect a new leader. It picks from the in-sync replicas, the followers that are fully up to date with the leader. We'll go deep on exactly what that means in Lesson 11. For now, the key thing is, Kafka promotes broker 1 to be the new leader. For the producer, it gets automatically redirected to broker 1. There's a brief pause, then data flows again normally. For the consumer, reads automatically resume from the new leader. No messages are lost because broker 1 already had a full copy of all the data. This is exactly why Kafka is fault-tolerant. The followers aren't decoration, they're the safety net. Let's zoom out and understand why Kafka was designed this way. Fault tolerance: if a broker goes down, another broker that already holds a copy steps up as leader. No data is lost. High throughput: because different partitions can have their leaders on different brokers, writes to those partitions happen in parallel across the cluster. This is one of the big reasons Kafka can handle millions of messages per second. Consistency: routing all writes through one leader means messages in a partition are always stored in the correct order. There are no conflicts, no race conditions. And automatic recovery: if a dead broker comes back online, it rejoins as a follower, catches up on any messages it missed, and becomes eligible to lead again. One thing you may have noticed in Lesson 7, in your single broker setup, Broker 0 was both the leader and the only replica for every partition. That works, but it means if Broker 0 goes down, your data is gone. Real production clusters always have multiple brokers for exactly this reason. Let's wrap up what you learned in this lesson. Every partition has exactly one leader broker, and all reads and all writes go through that leader. The other brokers holding copies are followers. They silently mirror the leader, always ready to take over if needed. Producers write to the leader, and consumers read from the leader. Different partitions of the same topic can have leaders on different brokers, which gives Kafka its parallel write performance. And when a leader fails, Kafka automatically elects a new one from the in-sync replicas, and no data is lost in the process. In the next lesson, we'll take this further with replication factor and ISR, unpacking exactly what in-sync replicas means, and how Kafka decides which followers are safe to promote to leader. See you at the next lesson.